RK24, okay, thank you. Okay, what is hypothesis testing and how does this hypothesis testing differ than the what we call the interval estimation? Okay, so last time we have talked about how does statistical inference can be done. Okay, RK86. Okay, remember we have this last time. Okay, for parameter estimation, we have point estimation, we have interval, and the second one will be hypothesis testing. And this involves the decision making. Now, here is involved only for estimation only. This part for estimation, this part for decision making. Okay, so that's what will be the difference between estimation and hypothesis testing. Now, if I were to put it in simple way, what is HT? Okay, is a procedure against described behavior. Okay, now when we say a procedure, then it will be involving 5 steps. 5 steps of procedure on how hypothesis testing is carried out. Okay, used to make a decision. Decision of what? Decision of your population. Okay, using your sample evidence. Make a decision for population using your sample evidence. So what sample evidence that we are talking about? Sample evidence could be X bar or sample evidence of the proportion sample. And from this, because we are collecting the sample, okay, we are going to make inference, make a division from our sample population. A sample mean, make a division, make the division for unknown mu. Okay, we use sample mean to know what will be the division for population mean. The same goes to p hat, make division, okay, for unknown p, your population proportion. Now, that is what is HT. Why HT? Okay, why do we need to use hypothesis testing? Why HT? Okay, the first one will be because, okay, HT is an essential procedure in statistics. Plus, the one that the note I giving you a lecture now will be until page, if I'm not mistaken, until page 87, something like 86. So this should cover until page 84 until 86. Okay. Now, essential in statistics. Okay. Number 2, HT evaluates hypothesis testing evaluates two mutually exclusive Two mutually exclusive statement. Okay, what statement? Okay, about population to determine which statement is best supported by the sample evidence. Okay, so in a nutshell, okay, you will need to test your two statement of hypothesis. Okay, and this statement is based on the requirement or on the needs of your what we call investigation. So if I were to write down, because we are talking about population mean and population proportion, let's look the first one for population mean. How can we write about this particular statement that we talk about? Okay, two mutually exclusive statements. Okay, about your population. So your statement will always refer to your population parameter. Okay, so what happened? Your statement can be this example of statement. Okay, I put it in green. Okay, so if I were to simplify, this statement would be what we call as null hypothesis, and the other one would be, the first one is null, second one would be alternative hypothesis. Alternative hypothesis. Okay, and this is known as H naught, and this one is H1. Okay, what is this? This is a claim assumed to be true until sample evidence indicate otherwise. This is like you are in court. Someone is found guilty after the evidence says so. Okay, this is what somewhat similar in hypothesis testing. That's why sometimes people say about hypothesis testing for the case, for the court case. Okay, what about H1? Okay, so H0 is a claim assumed to be true. So H1 will always be true until the sample evidence say the other way around. Means that prove that this the statement is wrong. What about H1? So H1 is a claim, okay, to be supported. Now the word supported and to be supported. Okay, underline after based on sample evidence. Okay, so I underline the word supported. Okay, assume to be true. Okay, so these are all a hint for you later on. Now, what kind of statement? If we are talking about, if we begin with one population, because our discussion is under one population, hypothesis testing. So we may have example of our statement would be, okay, first one, null hypothesis, mu is equal to mu naught. Alternative would be mu not equal to mu naught. Okay. Second one, null mu equal to mu naught. Alternative, mu is greater than mu naught. Greater than mu naught. The third one would be null mu equal to mu naught. Alternative would be mu less than mu naught. So class, we may have three types of tests. This is what we call two-tailed test. This is what we call right-tailed test. And this one is left-tailed test. Why so? Look at the what we call condition. This condition gives you the reason why we have two-tailed test. This one is greater than, so we are talking the area of to the right. Okay, to the right of your distribution. Because we are using Z. So it will be right tail test. This one is referring to the area to the left. Okay, that's why we call it as left tail test. And we are talking about two tail test. Okay, both tail are included. Okay, whereby okay, the concept of alpha that we have covered before. So this one will be alpha over 2. This one will be alpha over 2. This one only alpha. This one only alpha. Okay, so that would be among the concept of statement for your two tail, one tail, whether the left tail or right tail, and how does it affect in terms of the what we call the what we call illustration of your distribution. If you have two tail test, right tail test, left tail test. Okay, so that would be one example. Okay, now what are other things that I need to give you or let you know? All the value refers to mu naught. Okay, this mu naught is actually what we call as our hypothesized value of population mean. So in this case, we are talking about population mean. Means that this will be given in terms of value. Always given in terms of value. The value that you need to test. Whether your mu is actually equal to or less than or greater than to your hypothesized value. So these are among the what we call fundamental about hypothesis testing that you need to understand. Okay, so as for now, okay, having said that, what else should you know? Okay, so there will be critical value, there will be Z alpha over 2, Z alpha, finding the Z value. So all that will be included in your procedure of finding or making decision for your hypothesis testing. Let's see. Now we have discussed about what is hypothesis testing, why hypothesis testing. Now we are talking about how to perform the hypothesis testing. Okay, how to perform hypothesis testing. So let's say I just put HT. Okay, HT is hypothesis testing. Now there will be three different ways you can carry out the hypothesis testing. The first one would be okay. The first one is what we call traditional method. Okay, and the second one would be p-value method. And you can also make decision for your what we call hypothesis testing using your confidence interval. But there will be certain conditions for this kind of confidence interval. You will see later. Okay. Now let's see we move to the concept of how we can do the first hypothesis testing using the traditional method. Okay. hypothesis testing using traditional method. Okay, now how can we do that? So this is what we call the 5-step procedure, the one that I mentioned earlier. So there will be 5 steps involved in this traditional method. The first one, okay, step 1 would be identify claim, okay, and what we call state the H0 and H1. That would be your first step. So you should have what will be your null, H0, what will be your H1, and which of the statement is your claim. Okay. Number 2, you will have to find your critical value. Okay. Find critical value. So that will be referring to your Z alpha or Z alpha over 2. Number 3, find test statistic. Okay, no S here. So for your test statistic, you are going to find what is your Z, which is given by x bar minus mu divided by sigma over square root of E. Okay, so that will be your what we call test statistic. Okay. Now, of course, when we talk about sigma, so there will be cases where, remember again class, if known or unknown, okay, known sigma or unknown sigma. So if known, then you will use sigma. If unknown, then you will approximate using S. But for known, unknown sigma, there will be 2 cases, n less than 30 and greater than 30. So if less than 30, so you're going to use your T alpha over 2. So this one would be Z alpha over 2. Or just 2 power, yeah? So just 2 here. Okay. Now, let's say we continue. Okay. The fourth step would be make a decision. Make decision is always be reject H1, sorry, H0 or fail to reject H0. Either one. So that will be a fixed decision that you need to decide whether reject now or fail to reject now. And last but not least, make conclusion. Okay, make conclusion. Okay. I actually felt exhausted. I didn't stop from 1:30 until now. I feel like I'm just I will just stop here. Is it okay, class?
Okay,
Is it
madam.
okay if I stop here, or do you want me to discuss one example? One example